Hi, and welcome to today's lesson of the bare basics, which is on compound interest. Now, it's handy to note here that the compound interest formula can also be used for calculations of inflation. So, if you have a problem that deals with inflation, you know to use the formula that you're about to learn. So let's begin, and we'll begin with a reminder of what simple interest is. Simple interest was the amount of interest that was earned over a single period of time. The formula is interest is equal to the principal times the rate by the time or term. Now, if I was to reinvest both the principal and the interest that I'd earn in my simple interest calculation into a second investment for the same rate and term, we would gain more interest as our principal is actually higher than it was originally. We call this compounding. Okay, calculating compound interest can be done in two different ways. So let's look at a problem and work it through. Our problem is Tess invests $2,000 for 18 months at a rate of 2% per annum, compounding every 6 months. How much interest does she earn? Now, the investment on a whole is for quite a small amount of time, so we can easily do up our investment as a table, which has a series of simple interest calculations. So what we have here is our initial principal of $2,000. It's multiplied by a rate of 0.02 for a term of 6 months, so our interest earned will be $20. We then add the original $2,000 and the interest earned to get our new principal of $2,020. Once again, we multiply that by an interest rate of 0.02 for a term of half a year, excuse me, and the interest that we earn is $20.20. So, yet again, we add the 2020 to our original $2,020 and we get $2,040.20 as the principal for our final period of investment, which earns interest of $20.40. So overall, after 18 months, we are left with the amount of $2,060.60. Now, that's okay when your investment is only for a relatively small amount of time. Imagine if this investment went on for 20 years. It would get really tedious to work out our problem like this. For that reason, there's a rule for compound interest, and it is this. A is equal to P outside of 1 plus R all to the power of N. Now, that might sound a bit like gobbledygook to you, but it actually makes sense when you look at what each of the letters mean. So, A is the final amount after the investment. Okay, so think of A as afterwards. P, once again, stands for our principal. So that's the initial amount of the investment. R, again, is the interest rate, and that is a percentage. And here, N is the number of terms for the investment. So let's have a look at another example. So William invests $5,000 at an interest rate of 2.9% for a period of 10 years, compounding annually. So substituting into our formula, we have A, so our amount afterwards, is equal to our initial principal, that's $5,000, times 1 plus the interest rate, so 0.029, all to the power of 10. And when you calculate that, you get a result of $6,654.63. Now, the example that we used before had our investment compounding more frequently. So when we have smaller periods, we make a slight adjustment to our formula. So imagine this time William invests a second $5,000 at an interest rate of 2.9% for a period of 10 years, but this time it compounds quarterly. So we make a slight adjustment to our formula. This time we have our amount afterwards is equal to our principal plus 1 plus r divided by n, all to the power of nt. Now let's just have a look and think what this means. So when we're talking about n here, what we're looking for is the number of times per year that the investment compounds. And t will be the total amount of time. So when we substitute into our formula, we have A is equal to 5,000 because that's our principal, 1 plus 0.029, so that's our interest rate, but we divide it by 4 because it's paid 4 times a year. So if it's 2.9% annually, if it compounds every quarter, we have to divide by 4. And then this time, our index that we're multiplying it by, or we're up here, is going to be 4 times 10 because it happens 4 times a year for 10 years. And that's how we get that figure. And you'll see that it provides just a slightly higher return of $6,675.15. That marks the end of Bare Basics for today on compound interest. If you have any questions, just email me or ask in class. This has been your Bare Basics lesson on compound interest, helping make maths more bearable.